Welcome again to this channel. For this video, we'll be discussing another sample problem for the double integration method in solving beam deflections. And so for this problem, we're given with a beam which is supported by a pin support at A and a roller support at point B. And then we have the following loads. We have a distributed load of 3 kip per foot from A to B, so at a distance of 8 feet. And then we have 2 external moments applied at the free ends or the overhang ends at the left side and the right side. So the dimensions are given. We have 4, 8, and 4 feet. By the way, EI here is constant, so we just indicate it here that EI is constant. So ibig sabihin, homogeneous yung ating material, E is constant all throughout the beam. And yung I, ibig sabihin prismatic yung ating beam. So hindi nagbabago yung cross-section from this point to that point. So EI is constant. So ang required dito sa problem natin ay kunin yung equation ng elastic curve. Step 1 ay i-draw natin yung elastic curve. No? So ganito yung loading, meron tayong dalawang moments sa gilid. So i-bend niya yung beam na pa ganito, no? So dalawang moments na ganito. Tapos ito naman i-bend niya yung beam natin concave upwards. Ganito bali magiging deflection natin, magiging 0 sa A, may deflection somewhere dito, 0 na naman sa B, then meron naman tayong deflection na ganyan. So yan yung elastic curve natin at required ng problem na to ay hahanapan natin ng equation yan, yung elastic curve na yan. So bago tayo kumuha ng moment equation, yun yung second step natin after illustrating the deflection diagram. Yung second step ay kukuha tayo ng moment function para sa length ng beam. Bago natin makuha yung moment function as a function of x, mamaya papakita natin yung saan lalagay yung x. Kukuha muna tayo ng reaction sa point A and point B. Sa pagkuha ng reactions, mas convenient pa rin mag-sum up moments tayo at either point A or B. Simula tayo sa RAY. So meron tayong reaction dito na RAY. Dito naman meron tayong reaction na RB. Minsan hindi niya nilalagyan ng RBY, no? Kasi wala naman talagang ibang force dyan. RB lang. So hindi na necessary yung RBY kasi wala namang RBX. Pero dito, meron tayong dalawang reactions dito. Horizontal tsaka vertical kasi pin. So kailangan nating tawagin na RAY kasi meron talaga tayong reaction dito na RAX. Kaya lang 0 siya kasi wala namang ibang horizontal forces na present. So automatic yung RAX natin equal 0. Isulat na lang natin, baka merong naku-confuse, no? Equal 0 kasi wala namang ibang force na horizontal na present sa ating beam. So para makuha natin yung RAY, summation of moments tayo at point B equals 0. Dito sinusunod ko lang yung magiging direction ng RAY relative sa point B. Yan. So ginagawa ko ng positive yung direction ng RAY with respect to B. So kung ano yung reaction na kinukuha ko, yun na yung sinusunod ko na direction dito sa sign convention sa moment. Para paggawa ko ng equation, positive na agad yung RAY. So RAY, meron tayong moment arm na 8 feet. Tapos ito, opposite direction kasi pa-counterclockwise. So negative 3 times 8. Mukhang na yung reaction, no? Resultant, di reaction. Resultant equals 3 times 8. So, yung length times yung height times the length, yung magnitude ng distributed load. Tapos yung resultant natin nasa 8/2. So, yun na rin yung moment arm natin, no? So, distance ng resultant force from point B is 8/2. Tapos, meron tayong isang moment na external na opposite ng direction ng moment natin ng RAY. So, ibig sabihin, minus 5. Ito namang isang moment, pareho sila ng direction clockwise with respect to point B. So, plus 5 equals 0. So, magiging 0, we have RAY. Makakancel yung isang 8, no? Paglipat mo sa kabila, makakancel yung isang 8. Magiging 3 halves times 8. So, 8 times 3 is 24 divided by 2, that's 12. Keeps. Ang RBY naman natin, pwede natin kunin sa summation of forces along Y, equal 0. meron tayong upward force na RAY, which is 12 minus 3 times 8 minus or plus RB, kasi upward din yung assumption natin, no, sa reaction. So RB equals 12 minus 3 times 8. So 12 minus 3 times 8, this is 24, this is 12, this is 12 pounds. Pwede na actually hindi natin isolve, no, kasi by symmetry, tapos pareho lang i-share ng A tsaka B na reaction yung load. So ibig sabihin, paghahatian nila yung 3 times 8 na load na yan between each other, no? So 3 times 8 divided by 2 lang yung magiging hatian nilang dalawa. So dapat equal sila, 12 pounds, 12 kips, 12 kips. Yan. So yan yung reactions natin. Meron tayong RAY equals RBY equals 12 kips. Sulat lang natin dito. RAY equals RB equals 12 kips. Next step ay kukunin na natin yung moment equation as a function of x. Sa pagkuha ng moment equation as a function of x, draw lang natin ng beam natin ulit. So meron tayong moment na 5, dito meron tayong reaction na 12, dito meron din tayong reaction na 12, tapos meron tayong distributed load na 3 kips per foot. Lagyan na natin ng unit. Para lang natin ito ay kips doon. Ito naman kips. Ito naman 5 kip foot kasi moment. Ngayon, para makuha natin yung isang moment equation para sa lahat, yung single moment equation, dapat dito tayo mag-cut, no? Dito sa section na to, tapos i-consider natin yung left. Pero pag titingnan nyo, pagdating dito, iba yung behavior ng loading natin kasi meron tayong distributed load. Pagdating naman dito, may iba na yung moment equation kasi nag-iba na naman yung behavior ng load natin. Ang ginagawa natin dito, dinadagdagan natin to ng imaginary load. So meron tayong moment, meron tayong 12, meron din tayong 12, meron tayong 3. So dito na tayo mag-cut, no, as we've suggested earlier. Ito na yung cut natin. Meron tayong shear na downward, tapos moment na counterclockwise. This is as a function of x. Yung x natin dito manggagaling papunta dun. Yan yung x natin. Ang ginagawa natin dito para matuloy-tuloy yung equation natin, nagdadagdag tayo ng imaginary load na katumbas ng distributed load natin, no? Nagdadagdag din tayo dito sa baba. Kasi in the end, yung force na to, makaka-cancel out lang din naman sa force na to. So parang hindi ka na din nagdagdag ng load talaga sa side na to. Pero makakatulong lang yung pagdagdag mo nito kasi magiging continuous yung moment na equation na supposedly mapuputol siya sa banda dito. So ito ay 3 kips per foot din. Ito din ay 3 kips per foot para mabalance natin yung forces na madadagdag upward tsaka downward. So magka-cancel din to, so magiging 0 para rin hindi nagdagdag ng force, para din ganito lang din yung effect niya. Pero yung equation mo continuous na galing dito sa pag-cut mo papunta dun sa the right end of your beam. Ngayon, sa pagkuha ng moment, pwede din natin sabihin na kumuha tayo ng summation of moments at section. At the section equal 0, susundin naman natin ngayon yung direction ng moment of x. Yung parang reaction moment natin dito sa section. So, ito yung positive, yung direction ng moment of x natin. Ang mangyayari, meron tayong moment of x. Tapos meron tayong plus, yung mga kapareho niya ng direction. We have plus 5 plus 3 times yung length ng distributed load natin. We have x minus 4. Kasi ito yung x, tapos ito alam natin na 4. Sisulat na lang natin yung dimensions para hindi masyadong confusing. So meron tayong 4 feet, 8 feet, tsaka 4 feet. So bali yung length na to ay x minus 4, tapos yung moment arm niya is x minus 4 divided by 2 kasi nasa gitna yung resultant, no? So meron pa bang kapareho niya ng direction? Itong dalawa lang, no? So itong tatlong forces na to, may reaction na dalawa, tapos itong distributed load na upward, opposite direction siya, no? So minus 12 times, ang moment arm nitong 12 ay x minus 4, kasi ito yan, no? Yung distance na yan, ito yun, 12, itong moment arm sa section. And then itong isang 12 pa, meron tayong minus 12 times x minus 12. Ito yun, no? Ito yung moment arm niya. So x minus 12. Then we have the moment caused by the distributed load, which is directed upwards. So negative pa rin kasi opposite siya ng direction ng mx. So minus 3 times yung length niya is x minus 12 times yung moment arm is x minus 12 divided by 2. Kasi nga rectangular, nasa gitna yung resultant force ng distributed load. Equals 0. So diretsuhin na natin kasi since yung moment naman natin as a function of x is equal to EI times d squared y over dx squared. Minsan baka tinatamad na kayong magsulat ng ganito. Pwede nyo rin isulat lang na EI y prime, no? Pareho lang din naman yung d squared y and dx squared equals y prime. Tapos yung equation ng moment natin magiging positive kasi ililipat natin sa kabila. Magiging 12 x minus 4 plus 12 x minus 12, tapos meron tayong plus 3 over 2 x minus 12 squared. Ito na yun, no? Tapos minus ito, minus 5 minus 3 over 2 times x minus 4 squared. Tapos wala na, no? So ito na yung equation natin nung EI d squared y over dx squared or EI y prime. Ang next na gagawin natin is i-integrate natin tong equation na to. Ito, no? We will integrate this equation para makuha natin yung slope or yung dy over dx, at i-integrate natin ulit para makuha natin yung displacement or yung equation mismo ng displacement, no? As required by our given problem. First integration, makukuha natin is dy over dx or yung slope yan. So integral ng 12x minus 4 is 12 divided by 2, 6x minus 4 squared. Integral naman ng 12 times x minus 12 ay 12 divided by 2, which is 6x minus 12 squared din. Tapos meron tayong integral ng 3 halves divided by 3, magiging 1 half. X minus 12 cube. Tapos meron tayong integral ng negative 5 is 5x. Tapos meron tayong integral ng negative 3 halves divided by 3, magiging 1 half. X minus 4 cube. C1. Second integration, we will have the displacement times y. Ito yung hinahanap natin na yung y. Equals, ito naman magiging 6 divided by 3, that's 2 x minus 4 cube. And then ito naman magiging 2 din, di ba? 6 divided by 3 magiging 2 x minus 12 cube. Plus ito magiging divided by 4, so magiging 1 over 8 x minus 12 to the fourth. Tapos itong negative 5 magiging negative 5 halves x to the second power, no? And then magiging ito 4 divided by 1 half divided by 4 magiging 1/8 x minus 4 to the fourth plus c1x plus c2. So meron na tayong equation ngayon ng y, but meron pa tayong c1 at c2. Ngayon next ay boundary conditions. Okay, latag lang natin yung equation natin para makita natin as a single equation. So ito na yung output value ng second integration natin. Nilapag na natin na pa ganyan. Ngayon, dahil dito na to, i-compute na lang natin yung C1 and C2 using our boundary equations. So boundary equations, lalagyan lang natin BC. So first boundary equation natin is that at x equals 4, which is at the pin connection natin at point A, y equals 0. So therefore, substitute lang natin yung x equals 4 dito sa equation natin para makuha natin yung C1 and C2. So ito ay 0. Ito naman ay magiging 0 din. Ito, 4 minus 12. Bali, itong mga ganitong cases na magne-negative, ika-cancel out na natin yan as 0 kasi nasa labas na siya ng range ng ating x. So ang lowest na value ng x natin is 0 supposedly, no? So wala tayong negative na value kasi lalabas na siya sa range ng ating equation. So ito ay magiging 0 din, 0, this is 0. Ito ay 0 ulit. So C2 equals yung ang matitira na lang dito is ito, meron palang value to, no? Ito yung magiging 0. Ito merong value kasi x equals 4. And then C2. So ito ay negative 5 halves x squared. So magiging 5 halves times 4 squared plus 4 C1 plus C2 equals 0. Therefore, meron tayong equation ngayon ng C1 at saka C2. So, simplify pa natin. This is 40. 16 divided by 2 is 8 times 5. That's negative 40. So, pwede natin gamitin or pwede natin gawing C2 equals 40 minus 4 C1. So, ito na yung equation 1 natin na gagamitin natin mamaya para paghanap ng C2 at saka C1. Next na boundary equation natin is at x equals 12. Doon naman tayo sa roller na connection. Displacement natin equals 0 or deflection equals 0. So, substitute lang natin. Meron tayong 12 minus 4, that's 8. So, magiging 8 cube. Tapos ito magiging 0. Ito naman magiging 0. Ito naman magiging 5 halves. 12 pala to. 12 squared. Diba? Tapos ito magiging 12 minus 4, that's 8. Magiging 1/8. 8 to the 4th. Plus 12 C1 plus C2 equals 0. Kasi 0 to yung nasa kabila. So, evaluate lang natin to. You will have 2 times 8 raised to the power of 3 minus 5 times 12 squared divided by 2 minus, that's 8 to the power of 3 kasi makakancel yung isa. Tapos, yan na pala, no? So, magiging 152 or 152 plus 12 C1 plus C2 equals 0. Ito na yung magiging equation 2 natin. So, substitute lang natin yung equation 1 sa equation 2. Magiging ano to, no? So, C2 ilalagay natin dito sa magiging. So, substitute 1, 2, 2. You will have 152 plus 12 C1 plus 40 minus 4 C1 equals 0. So, simplify lang natin. Magiging 152 plus 40, 192. Tapos meron tayong 12 minus 4, that's 8. So, divided by 8. Ang C1 natin equals negative 24. And then C2, substitute natin ulit dito. So, that's negative 24 times 4, 96. Tapos 40 minus answer, C2 equals positive 1, 36. So, ang final na equation natin, papalitan na lang natin to dito. We have C1 is negative 24x plus 36. So, negative 24x plus 1, 36. So, ito na yung magiging final equation natin ng deflection or ng elastic curve, which is yung required ng problem natin. So, thank you ulit sa pakikinig at panonood, at sana ay may natutunan kayo ulit sa discussion natin. Sana ay hindi masyadong confusing yung solution. And see you again sa ating mga next na videos or next natin mga discussion and lectures. So, thank you again and see you around.